So now we're going to look at the last part of 1.7. And I'm hoping that we can finish up 1.7, then take a break, come back, and look at some questions off of our practice exam. So hopefully that we can get through that. So we're now again in 1.7, and we're going to talk about absolute value inequalities. Now, absolute value inequalities, well, they must be graphed. So these are all going to have to be graphed here. And when we look at these, we have two choices for the answers. So the answer is going to be one of the two choices. So the answers are always going to be shaded either in the middle, like this, or on the ends, like this. And they can have square brackets or they can have parentheses. And remember, greater than, less than, those again get parentheses. Greater than or equal to, less than or equal to, those are going to get our square brackets. So when we go to graph these, we have two different answer choices. It's either you shade the middle or you shade the ends. That is it. It is one or the other. Now we're going to solve them like they're an equal sign. So again, these are going to have to be solved and graphed. So we're going to solve and graph. What we do is we solve it first with the equals. So we break it out into our two equations. Now we're going to go ahead and box this so we don't lose our original, because we're going to have to check numbers back in the original. So what we first do is we take it and we get our two equations. So our two equations would be 3x plus 2 equals 5, or 3x plus 2 equals a negative 5. The textbook has you use a formula and different cases. We'll look at that a little bit, but I think this way is actually easier. So we break it up and we get our 2 points. So let's go ahead and solve each of these out. No different than what we did a moment ago. So move that 2 over. And then we've got our 3x. And 5 minus 2, that makes it a 3. And we'll divide by our 3. And so x equals 1. So move things around and we solved it. The other side, we do the same process. That makes that then a 3x equals a negative 7. We'll divide by our 3. And that leaves us with x equaling negative 7/3. Now, we are not completely done. Okay? Because this is an inequality, we have to add an extra step. So solve it. Just like an equality, it's just that when it's an inequality, we add an extra step. And what we do is we put our numbers on the number line in the correct order. And then that's going to make different regions. And we've got 1, region 2, and region 3. Now what we do, once we've got our regions, is we find out where 0's at. Okay, so we split this up into 3 separate parts. We need to locate 0 because we're going to check 0. The only number that we have to check is 0 in the original. So we're going to locate 0. So 0 is in region 2. So always make sure that you find that 0. So 0 is going to be right in region 2. Now we check x equals 0. You always check 0. 0 is the one that you're going to check every single time. And so we check that in the absolute value of 3x plus 2 is greater than or equal to 5. And we plug in our 0. Three times 0 is gone, so that gives you the absolute value of 2 is greater than 5, and is 2 larger than 5? Is this true or false here? Which one? Okay, so this would be false. Now, where is 0 located at? 0 is located right here in the middle. And we found the middle to be false. Now it always switches back and forth between true and false. These numbers are where it switches from true to false. So if it's false in the middle, then that means the outer edges must be true like that, because they always switch. Now, where do we shade? We shade the true regions. So we're going to shade the true part. So that means we're going to shade in here, and we're going to shade over here. Now, going back, look at your sign here, the inequality. It's greater than or equal to, so that means then that we use square brackets. Is everyone okay with that? Now, if that would have been true here, then what would it be? They switch back and forth. If this would have been true, then this would be false, true, false. In the middle, though, it's false. So they have to be opposites, so the middle is false, so the ends must be true. Now, how do we write our final answer in interval notation? Well, we do it just like we did earlier with the OR. So the final answer in interval notation is going to be this. Negative infinity with parentheses, comma, negative 7/3 with the square bracket. We use a U for union. And then we've got 1 to infinity. So that is going to be our final finished answer. And this is the graph that goes with it. And we're going to do several of these. I know there's something a little bit different. It's the same as the equal sign, though. All we do is have to graph them. Now, our choices, again, are either shaded on the outer edges or shaded in the middle, one or the other. If it's false in the middle, then you'll shade your outer edges. If it's true in the middle, you'll only shade the true part, which would be in the middle. We always check 0 because 0 is the easiest number to check. Unless one of your numbers is 0, then you got to pick a different one. But that very, very, very rarely happens. So let's try another one. Again, we're going to solve and graph these. Absolute value of minus 2x plus 4 is less than 8. Okay, so again, we're going to go through this one slowly to make sure we understand what to do. So first thing we do is we treat it like an equality. So we need to get our two equations. What would our two equations now look like? Well, we have to solve a minus 2x plus 4 equals 8, or a minus 2x plus 4 equals a negative 8. Remember, we have to get both of them. The or just means your answer can be either one. So now we're going to go ahead and solve it. So we'll move that 4 over with subtraction. Now we've got a minus 2x equals, looks like a positive 4 here. Divide by your negative 2. And that gives you x equals now negative 2. Repeat the process on the other side. Move your 4 over. Got a negative 2x equals now a negative 12. Divide by your negative 2. And so x equals, it looks like a positive 6. So that is what we've done before break. Now this is an inequality, so we have to do one extra step. We have to graph it. So now what we do is we take our two numbers and we place them on the number line. And that makes the three regions. Okay, now most of the time, but not always, 0 is going to be right in the middle. But it doesn't always have to be. So this one happens to be where? Where is 0 at? Okay, this is for numbers less than negative 2. Is 0 over here? Nope. Is it bigger than 6? Nope. Where is 0 at? Right here in the middle. So you find and you locate the 0. Very, very important. Now we take that 0 and we check. So we're going to check x equals 0, and we're going to check that back in the original. And we're going to see if it's going to be true or if it's going to be false. So we plugged in that 0, and we check it in our original, which remember our original was a minus 2x plus 4 in absolute values was less than 8. So we took that and we plugged in our 0. You just plug in 0 every time. That gives you then, those can cancel. That gives you the absolute value of 4. And what's the absolute value of 4? Well, it is 4. And now you can tell me if this is true or if this is false. Okay, is 4 smaller than 8? Is that true or false? Is 4 smaller than 8? Yes, true is 4 is smaller than 8. So that would make that then what? True. Okay, so what does that tell you then? 0 is right in the middle. This is true. If it's true, then what do we know about the outer edges? They have to switch. So that means the other two are going to be what? False. Now, where do we shade? We shade the true part, which is right here in the middle. Are we going to be using brackets or parentheses? Let's go back up and look. This is strictly less than. So what does that mean we're going to be using here? Parentheses. Okay, and then what does my answer look like in terms of interval notation? Well, my final answer would be -2 with parentheses, comma 6 with parentheses. We'll probably do 3 or 4 more of these to make sure we see how they work. Okay, so this is going to behave exactly like we did with the inequality, exact same type of problem. What do we need to do first? Well, before we can begin doing anything else, we need to move that 7 over, just like it's an equal sign. So the first step is going to be move that 7 over. And then that gives you our absolute value by itself. So that's the absolute value of -2x plus 1 is less than or equal to, we've got -2 plus 7, so that makes it a 5. We're going to go ahead and box that because that's the inequality that we're going to check it in. It's going to be easier to use that one than the original. So first things first, just like an equality, what do? Move that 7 over first. Now, just like an equality, we get our 2 equations. And what are my 2 equations going to now be? Well, my 2 equations would be -2x plus 1 equals 5. And we always put an or in between them. And a -2x plus 1, sorry about that, equals a what? -5. So nothing new. The only new part is the graphing. Now we solve them. So we move that 1 over with subtraction. And 5 minus 1, that's 4. Divide by our -2. That gives you then x equals now -2. Same process over here. Move that 1 over. And that makes it a -2x equals now a -6. We divide by our -2. Negative and negative makes it a +3, doesn't it? So we're halfway done. So we got the numbers. Now what do? Well, now we take our numbers and we place them on the number line in the correct order. So here's -2 and here's +3. That makes our regions. We've got 1, 2, and 3 regions. Where's my 0 at? Well, 0 again is going to fall where? 0 again is going to fall right in the middle, isn't it? Because it's in between -2 and 3. Is everyone okay with that so far? Now what do? Now we go back and we have to check 0. And we're going to check that 0 in this, in the highlighted version, which is the absolute value of -2x plus 1 is less than or equal to 5. Now you could use the original, it's not going to matter. It's just easier to use the one we moved that 7 over. But if you want to use the original that we began with, you can use that also. Doesn't matter. Now we plug in our zebra. -2 times 0 is 0. That's gone. The reason why we use 0 is the absolute easiest number to work with. So that's why we use it. And that gives you 1. Now, is this true or false here? Can someone tell me if this is going to be true or false? True. Okay. Why? Because remember, the inequality opens towards the larger number, and 5 is larger than 1, so that makes that true. Now, if that's true, then what do we know? Yep, we know it's true in the middle, so then the edges must be what? False. Are we going to be using square brackets or parentheses in the middle here? Yep, because of this, right? And now we've got it. There's our graph. And what does our answer look like in interval notation? Well, it looks like -2 with square brackets, comma 3 also with a square bracket. These are not difficult as long as you just follow that simple procedure. The textbook has you use cases, and we'll talk about the cases after break. But the cases, I think, are more confusing. I think it's easier just to check a number, and that also gets you ready for college algebra. Because in college algebra, we work with quadratic inequalities, and you have to check each region. So that gets you kind of ready for that. Let's look at one more. I think I'll pick a couple from our textbook. I can make them up, but sometimes we might as well use our textbook as well, because that's why we have it. 68, and this is on page 133. And if you want to look in your textbook, that's fine. If you want to just copy it down, that's fine too. And I'm picking this one just because of the negative here. So if I gave you this one, what would you want to do first? Well, do we have anything to move over first? Nope. There is nothing to move, so we should be okay with that. It's an inequality, so we know we're going to have to graph it. Where do we begin? Well, we begin with our two equations. So we've got 8 minus 10x equals 2, or 8 minus 10x equals a what? -2. So always get your two equations. Now we can solve it. And again, we're going to have to check, because this is an inequality, and we're going to check it in the original. So move that 8 over. And that gives you then a minus 10x equals a minus 6. We'll divide by our -10. And we're going to reduce this down a bit. So that is then going to reduce down to, it looks like, a positive 3 bits, isn't it? Okay, so there's one of them. Now we'll do the other one. Move the 8 over. -10x equals now a -10. Divide by your -10 and watch your signs. Negative and negative makes it a positive 1. So is everyone okay with that so far? So what did we do? 2 equations, we solved. Now, if this was an equals, we would be done. But we're not done because this is an inequality. So we have to do that extra step of graphing. So we put them now on our number line. So let's look at our number line here. Okay. We've got, make sure they're in the correct order. We've got 3/5, which is a little bit smaller than 1. Notice, and this is why I picked this one, notice where 0 is going to be at. Yep, we've got our 3 regions, and 0's not in the middle anymore, is it? Why not? Because it's 0 in between those 2 numbers. Nope, 0's back over here. So 0 can be in any of the regions. You only have to check that 0. That is it. You can pick any number you want to check, but I think 0 is the easiest. So now we've got this 0. So now we're going to check it back in our original. And we're going to check it in the absolute value of 8 minus 10x is greater than or equal to 2. So plug that 0 in. 0 makes that go away. So we've got 8 is greater than 2. Is that true now or false? Okay, 8 is definitely bigger than 2. So again, that would be then what? True. So 0 is back here in this region, and that region is true. What always happens with the signs? The signs do what now? Switch back and forth. So this is true. The middle would then be what? False. And the other edge would be what? True, right? Because it goes true, false, true. They always, always, always switch back and forth. Every single time they switch. So all you need to do is find one, and then you can complete the pattern. Now, what do we know? These have square brackets, correct? So that's going to be here and here. We shade our true regions, which are now on the ends. So this is negative infinity, and this is positive infinity. We always shade the true part, and in interval notation, it looks like negative infinity, comma, 3/5 with the square bracket. We use a U for union. We've got our square bracket, 1, comma, infinity. So is everyone okay with that? Let's do another one. Well, let's look at one that's got a decimal. How about question 88? So we're going to look at question 88 next year. And this again is on page 133. Okay, so question 88. So question 88, we've got decimals, and decimals are no different than whole numbers. They work the same. So we've got the absolute value of 0.5x minus 3.5 inside the absolute value bars, plus 0.2 is greater than or equal to 0.6. Now, what do we do first? Well, before we can make up our equations, what must be done? Can someone tell me what we must do first? Yep. Because that absolute value must be by itself alone on the left. So move that 0.2 over. Everything else stays the same. Okay, so we move that over, and that's what we've got there. Now we've got it set up. I'm going to go ahead and box this. Because we're going to have to check 0 in this here in a moment. So what do our two equations look like? Sometimes it's easier to make these a little darker so you make sure you know they're absolute value bars. Sometimes students make that mistake. What do my two equations look like? Well, it's 0.5x minus 3.5 equals 0.4. Or, what's our other one? 0.5x minus 3.5 equals a minus 0.4. So we now have our two equations. Move them over and solve. So add that 3.5. Use the calculator if you need to. So that is 0.5x equals now, looks like 3.9. You add them over. And then we've got 3.9. We're going to divide that by 0.5. And that leaves me then with x equaling 7.8. So there's one of them. Repeat the process on the other side. That leaves you then with 0.5 equals now, adding those together, looks like 3.1. Divide by your 0.5. That leaves you with x equaling now 6.2. Is everyone kind of okay with what we did? So we moved that 0.2 over. We split it up then. We got our two equations. Are we done yet? No. Why not? We have to graph it. Make sure you put them in the correct order on the number line. Very, very important that you put them in the correct order. So we've got 6.2 over here. 7.8 is the larger number. We always find our 0. Is 0 in the second region anymore? No. Where's 0 going to be at? Yep, 0 is going to be clear over here. Always identify where the 0 is. That's why we've got the three regions. Now we're going to check it. So now we're going to check x equals 0. And we check it in the absolute value of 0.5 times 0 minus 3.5. It's greater than 0.4. Gone. What's the absolute value of a minus 3.5 again? 3.5. And is 3.5 bigger than 0.4? Yes, it is. So that would make this then true. So what does that mean our signs go? It goes true in region 1, false, and then what? True. Now, we are going to use square brackets. Why are we going to use square brackets? Because it has the bar underneath. We're going to combine these with a U for union. So this is negative infinity. This is positive infinity. So what does it now look like in interval notation? Well, it looks like negative infinity with parentheses, comma, 6.2 with square brackets. We've got a U for union, 7.8 with square brackets, comma, infinity with a what? With a parentheses there. I want to look at one more type of these before we take a break. Come back and look at some special cases. We've already talked about equalities and how to solve them. Now we need to talk about how to solve an absolute value equaling another absolute value. So we're going to try and solve this. We're going to try and solve the absolute value of x minus 4 equals the absolute value of 2x plus 3. So, are we going to have to graph this one? No. Why not? It's an equal sign, right? Okay. Now, it is a little bit different because we've got an absolute value equaling another absolute value. But we solve it the same way we've done before, which is get two equations. And the first one we get by simply dropping the bars. So the first one is simply going to be x minus 4 equals 2x plus 3. Now the second one, what we do is we keep the left-hand side the same, but we change the right-hand side. So we put a negative out in front. And then that negative is going to be distributed through. So it's the same as what we've done. It's just that we have to distribute that negative through now. So one equation, we drop the bars. The other equation, we switch the signs on the right. We do that by distributing through a negative. I don't like to use that word switch signs because then students sometimes change one but not both of them. So I always like to use the negative and distribute it through. And we'll do probably maybe 2 if we need to, 3 of them. And then take a short break. We're not going to have to graph these again because this is an equal sign. So move that 2x over and add that 4 over. So when I do that, that leaves you then with a negative x. The 4's cancel. 2x's cancel. And 3 and 4 makes it a 7. Divide by your negative 1. So one solution is negative 7. What about the other one? Well, the other one, we do the same thing, but this negative gets distributed through. So that makes that then a minus 2x and a minus 3. So we just move things around again. So we add our 2x and we add our 4. X and a 2x makes it 3x. 4's cancel. 2x's cancel. And minus 3 plus 4 leaves you with a 1. Divide by our 3. And then what do we have? We have x now equals what? 1/3. There's your two solutions. Let's do another one. Why do we not have to graph this one? Right? Not an inequality. So we don't have to graph it. Only ones we have to graph are inequalities. Equalities, you do not have to graph. So let's try another one of these. And I'll just pick one from the textbook here. Let me see if I can't find one here. How about question 94? And this is on page 134. Question 94. And we've got 2/3 x minus 2 equals the absolute value of 1/3 x plus 3. So both sides are absolute values. We are going to have to clear our fractions. So how many equations are we going to get? 2. What's my first one look like? 2/3 x minus 2 equals 1/3 x plus 3. What about the other one? 2/3 x minus 2 equals, use a negative here, parentheses, 1/3 x plus 3. And that negative is going to have to be distributed through. So again, we'll do each one separately. We want to clear out our fractions, so how do we do that? Well, we need to get rid of these 3's down below. So I'm going to multiply everything by a 3. It's going to clear out all of my fractions, and that makes it then canceling. 2x, 3 times a negative 2 is a negative 6, equals, the 3's cancel, x, 3 times 3 makes it a 9. Move things around and solve, so move that x over, add your 6. Simple enough. That leaves you then with x equaling now, thank you, 15. We do the same process on the other side. Make sure that making the mistakes, but everything looks right here, I believe. It's easy to make a mistake on a sign, so if I make a mistake, be sure and tell me. On the other side, we've got 2/3 x minus 2. We're going to distribute that negative through, and that's going to make that a minus 1/3 x minus 3. We'll multiply it out again all by 3. So those cancel. That leaves you with a 2x minus 6 equals a minus x minus 9. Add your x to each side and add your 6 as well. So what does that leave me with? Well, 2x plus x, that makes it a 3x. 6's cancel. The x's cancel. Minus 9 plus 6 makes it a minus 3. Divide by your 3, and so your other solution is x equals a negative 1. I think we'll do one more, and then we'll take a short break. So we'll pick an easier one. So that was question 94. we had to clear the fractions. Clear the fractions out to get our two solutions. So 96 should be a little bit easier because this one doesn't have any fractions to worry about. Again, page 134. We're going to look at question 96. Got the absolute value of 13x equals the absolute value of 2x plus 1. We've got an equal sign, so that tells me that I've got to come up with my two equations here. And what are my two equations going to look like? Well, they're going to be 13x equals 2x plus 1, or 13x equals a negative parentheses 2x plus 1. So there's that one there. And we'll go ahead and solve this out. So move that 2x over again with subtraction. And that leaves you then with 11x equals 1. Divide by our 11. So x equals 1 over 11. Simple enough there. What about the other one? What do? Distribute that negative through. And that gives you then 13x equals a minus 2x minus 1. We're going to add our 2x to each side. And that gives me then 15x equals a negative 1. Divide by your 15. And x now equals a negative 1 over 15. There's your two solutions, and we do not need to graph it. Why not? Because it's an equal sign. Let's go ahead now and take a short break, and then we'll meet back here at 10:35. So let's meet back here at 10:35.